All right, my beautiful followers, good afternoon and welcome to our today's lesson where we always come to learn together. So today we want to answer a question which we received from one of our previous videos. So this question has to do with relay. So this follower asked us to give him a better explanation on how a relay works. So we looked around and we were able to find this type of relay. So I think this is one of the most common relays we use these days. It is one of the common ones. So we're going to use this one to make our explanation and see whether that is going to answer all the questions on a relay. So, but first, what is a relay? A relay is just another electromagnetic switch. It is a switch that cannot operate without the presence of a signal, and that signal comes in form of power. That power could be AC or DC. This particular one we have here is rated 220 volts, and the contacts are rated 10 amps. Okay, so for you to identify this easily, you look at the coil. You are going to see the voltage rating boldly written on the body of the coil. So what happens here is that if you look inside this place, okay, let us open it and have a closer look of what this looks like. So you just gently do it that way and then you slide it out. It is not difficult to dismember. Okay, so what we have here is we have the coil, which is rated 220 volts. We have the frame, which is holding the coil, and then also this movable arm, which is spring-loaded. This spring, what it does is that after being attracted, when the signal is removed, it should be able to return to its original position. So this coil has two terminals, which goes all the way to pins 7 and pin 2. It goes to pin 7 and pin 2. That is this coil. And then if you look at this side, you're going to see 3 contacts. This one in the middle that is movable, and this stationary one, and this second stationary one. So this one that is stationary, where this common one is resting on, is the normally closed contact, while this one that is open is normally open contact. If you turn to the other side of this relay, you are going to see the same thing, a normally closed contact and a normally open contact with the movable arm in the middle, which is the common. So now, these terminals are connected to these pins, making it a total of 8 pins, which is also numbered 1, 2, 3, all the way to number 8. So what happens here is that when we energize this relay, when 220 volts is connected to this relay through pin 2 and 7, this movable arm will be attracted by this coil, which acts as a solenoid, and it moves. Look at this place. It moves that way. So what happens is that the normally closed opens and it makes with the normally open, and it closes like that. When the energy is removed, it will return back to normally closed. So looking at this pin, it's just like the timer we talked about the last time. These pins cannot be soldered on, or should not be soldered on, but should be mounted on a base like this, where it is plugged in this way. So let us assemble it back gently until it slides in before you can lock it like that. So it's locked. So what we have here is the base, and this base is also numbered from 1, 2, 3, 4, 5, 6, 7, 8. So what happens here when you assemble these 2 units, the relay and the base? What you have is what I'm going to show you. We have 2 terminals, this one and this one, which is the coil terminal. And this is pin 2 and this is pin 7. Now we also have another terminal which is pin 1. And then we have another terminal which is pin 4. We have another terminal which is pin 3. So this one is like this. What that means is that pin 1 is common, pin 4 is normally closed, while pin 3 is normally open. If you look at this picture, you are going to see the same thing. The diagram is here. Pin 1 is resting on pin 4, which means that pin 4 is normally closed, while pin 3 is away from it, meaning pin 3 is the normally open, while 1 is common. It is common because it moves between 3 and 4, 3 and 4, that way. So this is what we have on one side. Then on the other side, we have another common pin, which is pin 8, which rests on another pin 5 with another pin 6. What that means is that pin 8 is the common, pin 5 is the normally closed, and pin 6 is the normally open. So when you send in 220 volts AC into this coil, pin 8 will leave pin 5 and make contact with pin 6, while pin 1 will leave pin 4 and make contact with pin 3. So from the way it is right now, what we are going to do is we can send in power into the coil, which is, the coil is pin 7 and pin 2, that way, by sending power here. So we're going to do that straight away, quickly. Okay, so having done this, the next thing to do is to plug in the relay. And you plug the relay by making sure that this notch here corresponds with this groove here. So you plug it in, facing it like that, and this is in. So for us to see what is happening inside, I'm going to turn it to this side while I close the breaker. Please pay attention to the movement here. It's going to move from normally closed to normally open. So when you energize, it moves that way, and when you de-energize, it returns. Do it again, and off, on, and off. So we turn it to the other side, and do it again, on, off, on, off. Okay, so we can also, to verify, use our continuity tester. We'll get our multimeter. We have our multimeter here, so set it to continuity. All right, so what that means is that here, looking at this one, pin 1 and pin 4 are making contact. So pin 1 is directly connected to normally closed. This is our pin 1, and it is connected to pin 4. How do we see this pin 4? This is pin 4 here. So this one and this one are connected. You see, they are connected. And then pin 8 and pin 5 are connected. This is pin 5 here, and this is pin 8. So they are connected. So that is normally closed here and normally closed here. This one is normally open, and this one is normally open. This one can only close when we energize this coil. So when we energize the coil, you see now that this normally closed is now open, and this normally open is now closed. You check on the other side again, you see that this normally closed is now open, and this normally open is now closed. So this is what you need to know about a relays. And now we can use this relay to switch on a big contactor like this to enable us power a heavier load. And how do we achieve it? We just need to take our power, pass it through one of the commons, and then take that power from one of the normally open. What I mean is, if we have connected our mains from here to the coil, we can take, let's say this is our neutral, and this is the live wire. We now take from this live wire and take it all the way to pin 1, and then take from pin 3 to the coil of our contactor. So we're now going to have our contactor here, right? And this one also comes back to the neutral. So you see that when we energize this coil, we can now use this contact of 10 amps to drive a load here that is rated up to 60 amps or more. So how we're going to do that is we switch off power, and then get our tool, do this. Of course, you have to remove the relay. Take your power from here. So we're going to connect it to pin 1. Connect it to pin 1. So what is going to happen here is that when we energize this coil on this pin 7 and pin 2, this power is going to come to pin 1, which is the common, this one. This is pin 1. Let me level it properly. This is pin 1. So connect it here. That is from here to here, which is from here to here. And then we have this power here already. But when we energize it, we're going to have it here. So we take this power from here to the coil of our contactor. So we're going to take this one from not pin 4, from pin 3, which is our normally open. So taking it from pin 3. This is pin 3. And then, of course, the remaining terminal of the contactor, which is this one, I'm going to take it to neutral. The closest place where we can find our neutral is on pin 2. Just we're going to slack it a little bit and insert this one also there. So we can now plug in our relay. So when we close our breaker, this contactor should be able to close that way. Going to close. So this is exactly how a relay works. Now, there is a difference between this relay and the timer, which we we did the last time. So if we remove this relay and then we put in our timer, the difference is that when we close this breaker, because it is connected on this particular terminal or this particular contact of 1, 3, and 4, this particular terminal of our timer behaves exactly like a relay. But these other terminals, pin 8, 5, and 6, that is the only ones that are affected by the delay on this guy. So if we change the connection, because if we close this one, it's going to behave exactly like the relay, this way. But if we change the connection, so if we remove this one from pin 1, which is this one, we remove it from pin 1 and then we take it to pin 8. This is pin 8. Take it to this pin 8. And then we remove this one. Remove this one, which is this one that is connected to pin 3. That is the coil of this contactor. If we remove it, and then instead of leaving it on 3, we take it to pin 6. This is pin 6. We slack this out and then insert this one in. Tighten it quickly. Plug in our timer. Set it to around 5 seconds, thereabout. And then if we close our breaker like that, after 5 seconds delay, the thereabout, we stop again. We put it on. This one delays. But if we take it out and put in our relay again, if we put in our relay, immediately you close this one, that guy closes. The reason is that this one does not have a timer, while this one has a timer. The connections are the same, but one part of this timer behaves as a timer, while the other part of this timer, this one, behaves as a relay. But in relay, both this side and this side all behave like relay. There is no time delay. So if you like this video, please share with your friends and let me know in the comment section. And then, of course, follow me for more tips on power. Thank you very much.